Hello, in today's video we will be taking a look at the Dragon High Flow Hotend from Phaetus. Now this Hotend was provided via Banggood for review and evaluation. No money was exchanged for this review. The Hotend was simply provided on the condition that I do a review on it. If you would like to purchase this Hotend, there will be an affiliate link below. So starting off, the Hotend comes in this nice little box here. Opening it up, we do have the Hotend itself. It comes with the V6 groove mount pre-installed. We have a silicone sock, a 0.4 copper-plated nozzle. We have a wrench, some Allen keys, screws, an extra installation sock, and a Bowden tube clip. And after installing it, I did a PID tune, a pressure advance calibration, and a quick flow test. Now for the Hotend, it was installed in my Voron V2.4. For that, I had to remove the groove mount adapter. If you are planning to use this Hotend in anything that uses a groove mount, it is simply a drop-in. However, if you do wish to rigid mount it, you will have to remove the groove mount to get access at the 4 screws on top. And this is simply done by removing 2 screws underneath. Now, the first thing I want to check is with most high flow Hotends, there's usually an excessive amount of stringing when using smaller diameter nozzles. So the first thing I did was print a Benchy. Now this was printed at 0.2 layer height with a 0.4 millimeter nozzle. And as you can see, this came out very clean. I'm actually legit impressed by how little to no stringing there is. Everything prints well, and any minor defects that I can see can mostly be attributed to slicer settings, and the Hotend itself performed flawlessly. I also printed a Benchy, and this was in eSun ABS Plus. So in terms of stringiness with a 0.4 millimeter nozzle, I will say it's not a big issue compared to most standard flow Hotends. Now, of course, it's a high flow Hotend. We are going to want to print with a big nozzle. So I printed 2 objects here. This is a Flexi Dinosaur. This was at a 0.8 millimeter nozzle, 0.4 layer height. Again, this printed beautifully. And we also have this vase mode print of a Christmas tree. Again, 0.8 millimeter nozzle, 0.4 layer height. And this was printed in eSun PLA+. Now, both those prints were printed at what I would consider my standard Voron speeds of 60, 90, 120. You can see them here. And just for kicks, I threw in a Benchy and I cranked the speeds up as fast as I could. So this was a 0.8 millimeter nozzle at, I believe, 0.6 millimeter layer height. This was printed at 300 millimeters a second, 5,000 acceleration. And this is a 12-minute Benchy. Now, obviously, there were some issues. The smokestack broke off, but this was a 12-minute Benchy. And other than issues pertaining to the fact that the plastic did not have enough cooling, and that's where the key to fast printing comes from. While you can print extremely fast with a 0.4 millimeter nozzle, that does not usually lead to good quality. For example, this was a Benchy printed with a 0.4 millimeter nozzle in ABS at 300 millimeters a second, but this took over twice the amount of time as this Benchy. And while the quality is a bit better, it's still not anything I would be impressed about, as some plastics do not like to be printed at that rate, and it leads to issues of print quality that you simply cannot overcome. Now on to what I would consider to be the major advantage of high flow nozzles, and that is printing at normal high speeds, but with larger nozzles. Now, these 4 parts here are structural components for the Voron V2.4. These were all printed in eSun ABS Plus. This printed in approximately 2/3 the time that it would normally take with a 0.4 millimeter nozzle at the same slicer settings. So we have the 80 tooth gear here. We have the front fan housing for the afterburner, and we have the A motor mount. And these 2 parts fit together like so. Again, any minor issues I can see, I can simply attribute to not having a perfectly tuned slicer profile, but these came with major time savings by simply using a larger nozzle. And with the larger nozzle and the high flow Hotend, I did not run into any under extrusion issues like I normally would with a standard flow Hotend at these speeds with a nozzle this size. Now, just to verify print quality, I did do some dimensional accuracy tests and also some tolerance tests. So we have 2 objects here that thread together. And again, these are with the 0.6 millimeter nozzle, 0.3 layer height. Everything printed clean. Everything meshes together perfectly. And we do have a press fit bearing that fits perfectly into its hole. And just for fun, I also printed this with the 0.6 millimeter nozzle. Now this is a splicer mask from BioShock for those unfamiliar. This was printed vertically with some supports that easily broke off here under the eyes, and that was it. So it printed vertically such as that. This was printed in some 5-year-old MakerBot high impact polystyrene, and the total print time for this object at 609120 came in at just under 7 hours. So as you can see, I'm fairly impressed with the quality of this Hotend, and that brings me to my next point and the hardest part about reviewing Hotends. And the hardest part about reviewing Hotends is the fact that all these Hotends are good. All these Hotends, if you take the time to properly tune your printer and have a tweaked profile setting, will print good benchies all day long. In fact, this benchy right here was the very first print off an i3 I built out of spare parts using a AliExpress V6 and default Cura profile settings for the most part. So why should you choose one of these Hotends over the other? And why should you choose the Phaetus Dragon High Flow? It comes down to creature comforts and what you are looking to print and how you want to print it. The big things for the Phaetus Dragon High Flow are the rigid mounting, the high flow output, the one-handed nozzle changes with the fixed heater block. On Hotend designs such as the V6, if you go to change your nozzle without grabbing your heater block, the whole thing rotates. Okay, this is true of the Dragon as well. However, with the Dragon Hotend and the Slice Mosquito, for example, since the heater block is rigid mounted, you can change the nozzle one-handed. The other advantage with having a rigid heater block is the heat break itself can be thinner. And as you can see with the high flow, the melt zone extends all the way up to here. And this is why you have the insulating sock. And right there, you can see the heat break. And that's a small gap of surgical steel versus on this V6 here, it's much thicker and it is structural. So in the event of a nozzle crash, you do risk damaging your heat break. With this, in the rigid mounting, you're less likely to damage it, and it can be thinner, preventing heat creep issues. I have also in tested found that this style of heat sink, being out of copper, requires much less active cooling than a V6. With these ones in an enclosed printer, I required a 4020 fan to keep them cool. With these, a cheap 4010 fan has no problem preventing heat creep issues. We also have the rigid mounting so that there's no chance of your heatsink rotating, whereas with groove mount, it can rotate on you if it's not properly secured. And also, in terms of nozzles, if you are looking for a high flow Hotend and you want to go with the Volcano, it uses not quite proprietary, but it does use longer nozzles. With the Phaetus Dragon, it uses the standard V6 style nozzle that is common and ubiquitous anywhere. Actually, at this point, I'm going to install the nozzle that came with it. But before I do that, you can see the portion of the heat break that extends all the way to the nozzle is the very thin surgical stainless tube. Encased around that, though, is copper. And that is what the extended melt zone is made out of. And that gives you a larger melt zone and more thermal contact between the nozzle. So this allows better heat transfer to the filament through the whole melt zone. It also allows you to cold tighten because copper and copper plated or brass will expand into each other under heat. So you don't need to heat torque these nozzles. You can install them cold and then heat up. And I haven't had any issues. And I've been doing that with this style of Hotends for years now with no issues. So what Hotend should you choose? Frankly, I'm extremely impressed with the Phaetus Dragon High Flow. Its performance with a standard 0.4 millimeter nozzle has blown me away. I did not have any of the downsides that I was worried about with a high flow Hotend at standard nozzle sizes. And its performance with the larger nozzles has thoroughly impressed me as well. Now, there are some minor downsides. It does use a slightly different sock design. So while you can use a V6 style sock, it doesn't quite clip on as well due to these notches on the side here. You won't get the same amount of support as a domestic Hotend, such as the Sliced Mosquito. For a lot of hobbyists, it does come down to price. It is the elephant in the room, and you can get 2 of these for the cost of 1 of these. In my market, it's almost 3 of these for the cost of these. It really depends on where you are in the world and availability. And if you are looking to upgrade from a V6 or looking for a Hotend that isn't as large as the Volcano, that is still a high flow output, this is an attractive proposition for you. It also does come with the rigid mountain and allows for the one-handed nozzle changes, which after using printers with that setup for quite a while now is something I'm not going to want to get rid of anytime soon. Now they do make a standard flow variant of this Hotend as well. And for those that are only ever really looking to print with a 0.4 millimeter nozzle, I would actually recommend sticking with the standard flow. While I haven't had issues with the high flow, with it being a high flow does allow for more variables in terms of tuning and tweaking. So you may get away with a simpler setup and less issue with a standard flow Hotend. Again, only if you're ever going to stay with those small sizes. But if you are going to look for printing with a 0.6 or 0.8 millimeter nozzle at high speeds, I do highly recommend looking at the Phaetus High Flow Dragon. This Hotend will actually be the permanent Hotend in my Voron V2.4, the taller one, going forward. I hope you have found this video informative. Again, I would like to thank Banggood for providing the Hotend for review and evaluation. If you would like to purchase one of these from Banggood, there is an affiliate link below. I do receive a small kickback from purchasing it from there. Also, if you did like the review, don't forget to hit that like button below. If you'd like to see more content such as this, please subscribe to the channel. I do weekly printer build and Q&A streams, and I do have a Twitter now as well at 3DP Nero. Follow me there for some updates on upcoming projects, pictures of current prints, and projects in progress. Thank you, and have a great day.